right, so we're looking to find the x-intercepts of this function. You can see the secant function graphed off to the right there. So finding x-intercepts of a trig function is going to work the same as any other function. We're going to start by setting y equal to 0, because that's all the locations where our function's going to cross the x-intercepts. We're going to have 0 equals 1/2 secant 2 theta plus 1. And I now want to work on isolating this secant 2 theta. So I'm going to subtract 1 from both sides. So we get -1 equals 1/2 secant of 2 theta. And then I'm going to multiply both sides by 2. So we'll get that -2 equals secant of 2 theta. All right. So what I want to do next is I want to use the inverse function. So secant's inverse function is simply labeled as inverse secant, so secant to the -1. So we're going to take the inverse secant of both sides, not secant to theta. So just like any other inverse function, addition, subtraction, they kind of, we often say, cancel each other out. So these guys kind of drop off and we're left with the inverse secant of -2 equals 2 theta. And we want to go ahead and work through finding theta now. Okay, so we're going to use one of our other trig identities in this location. So that's the relationship between inverse secant and inverse cosine. So secant, inverse secant of theta is going to go ahead and equal inverse cosine of 1 over theta. So we're going to go ahead and use that relationship in order to start working with cosine, which we're a little bit more familiar with. So if this is secant inverse of -2, this is really cosine inverse cosine of -1/2 equals 2 theta. So in order to evaluate inverse cosine, what we have to do is ask ourselves where on the unit circle, so we're kind of asking ourselves where on the unit circle, if I take cosine of some theta value, I get -1/2. So that's sort of how we go about evaluating that. And the answer is 2 locations. So if we're thinking about our unit circle, there are 2 locations where our x value, right, cosine is, our x value is going to be negative. So here in the second quadrant and the third quadrant. So we would be at a, right here, so we would be at a 2 pi over 3, and then we would also be at a 4 pi over 3. So this is a good time to reference your unit circle. Okay, so because we have 2 possible locations where cosine theta is -1/2, we have to solve 2 different equations. So first off, we could have that 2 pi over 3 equals 2 theta, or we could have that 4 pi over 3 equals 2 theta. So now we just want to go ahead and solve, so divide both sides by 2, or I prefer to think about it as multiplying by 1/2. So we would have 2 pi over 6 equals theta, making sure we reduce. Pi over 3 equals theta. And then we're also looking at this guy over here. So again, multiplying by 1/2, 4 pi over 6 equals theta, reducing 2 pi over 3 equals theta. So if we're thinking about this on our graph, these are just the first 2 intercepts that we have. So it's a little small, but hopefully you can see that's those two intercepts. But we have more, right? As our function continues, we're going to continue to have intercepts, those two right there. We're going to have intercepts over here, and so on and so forth forever. So we need to think about how often do these periods occur. So for that, we're going to go back, or excuse me, how often do these x-intercepts occur? And we are going to use our period. So our period is pi, which means that these intercepts are going to repeat every pi. So essentially, this first intercept is pi away from our second or our third, and then so on and so forth, moving on. So if we're looking at writing our x-intercepts for our final answer, we're going to take the first one. It's going to be pi over 3, and that's going to happen every n pi. And our second one is going to be 2 pi over 3 plus n pi as well. So down in this kind of bottom corner, that's your final answer for your intercepts. All right, we're going to do another. So if you're good, you can, I'd suggest watching the second example because this is, a little tricky, and we use a couple of little tricks in here. But if you don't need the second example, feel free to stop here. All right, so next one we're going to look at is, again, another secant function. So it doesn't really matter if it's secant or cosecant, sort of the same things apply, same identities. Check out your trig identity sheet and all that good stuff. This one's just a little on the nastier side. So we are going to use a calculator. So refer to that Desmos calculator if you need to. So again, we're looking at the function y equals 1/2 secant 2 theta plus 7 pi over 6 plus 2. So we've added another shift here. We've added a horizontal shift as well as that vertical shift tacked on at the end, that plus 2. So we're looking at intercepts. So we're going to go ahead and again set y equal to 0. And we're going to isolate, that needs to be a plus. We're going to isolate the secant 2 theta plus 7 pi over 6 part. I'm going to do that all in one step because I think you should be okay to go ahead and do that one on your own. So we should end up with a -4 equals secant 2 theta plus 7 pi over 6. Okay, so again, we want to kind of get rid of this whole secant thing, evaluating our theta here. So we don't want secant of some expression with theta. We want secant of a value, right? An explicit value. So I'm going to use the inverse secant on both sides. So inverse secant of -4 equals the inverse secant of secant 2 theta plus 7 pi over 6. Okay, so again, inverse secant, secant, we can kind of think of those as canceling each other out, leaving us with just the inside bits, which is what we want. Oop, not equals, plus. And then we have secant inverse of -4 on the right. So we're going to, again, use that property, inverse secant of some value x equals inverse cosine of 1 over x, because I always just want to be dealing with sine or cosine or tangent whenever possible. So we're going to rewrite this as inverse cosine of -1/4 equals 2 theta plus 7 pi over 6. Okay, so here we want to be looking at this inverse cosine of -1/4. So we evaluate the inverses by asking, okay, if I had my original function cosine, what theta value would get me -1/4? And if you look at your unit circle, none of those get us -1/4, right? So this is where we are going to use a calculator, okay? So just like before, we're expecting two solutions. So if we think about our cosine function, think about our cosine function, we know that cosine is going to equal a negative value in two locations, right? In the second and in the third quadrant. So we know we're going to get two things. So the first thing we're going to type is we're actually going to use inverse cosine. So either in Wolfram Alpha, which I love, or the Desmos calculator, go ahead and type cosine inverse of -1/4. Or often you can input it as arc. So ARCCOS, that is of theta, is the same thing as cosine inverse of theta to a calculator. So if you're using Desmos, probably easier to type that in instead of doing the to the -1. And the first answer that we're going to get out is going to be about 1.823. All right, so that's going to make up our first one. So 1.823 equals 2 theta plus 7 pi over 6. This gets a little nasty. So if we're thinking about that, that basically means this angle right here. So this is, a decimal approximation of some value with pi. All right, so we want to think about how we can find our second value. So our first value, we kind of went around to this first location. That's our approximately 1.823. And then we almost want to think about this in reverse. So these two red lines, if we go backwards, they're the same kind of distance, which isn't a great way to describe it. So if I went kind of counterclockwise, 1.823, if I go clockwise, I would be going -1.82. And that is what we are going to use for our second inverse cosine of -1/4 value. Now, it's not going to get us to the intercept that we want, because we kind of but it's gonna work out okay. We'll see what's gonna happen there. Okay, so the next one we're gonna do is the -1.823 equals 2 pi plus 7 pi over 6. And now we're gonna be working with calculators. Try to keep your decimals out pretty far. So the first one, I'm going to subtract 7 pi over 6, divide both sides by 2, and we are going ahead and we're going to get a -0.9209 is about the theta value here. And I'm going to do the same, so we're going to kind of solving two different things. I'm going to do the same to the second one. So subtract 7 pi over 6, divide by 2, and we're going to get a -2.7443 is about theta, and I wrote pi for some reason, so let's fix that. Okay, so here's the problem. When we're writing our consecutive or sequential x-intercepts, however you want to say that, we want to be kind of looking at these intercepts right here a little bit, or at least our first positive intercepts. We don't really want to be dealing with these negative intercepts. So what I'm going to do is I'm just going to sort of fast forward these intercepts by one period, and I'm just going to do that by adding my periods. So I'm just going to add pi to both of these guys. All right, so if I add pi to my first one, I get 2.2207 is about a theta value there. And then my next one is 0.3973 is about theta. So we actually sort of went and found, use a different color, these two, kind of our first two positive intercepts just by shuffling forward. So we kind of were back here and we just shuffled forward because we wanted to work with a positive intercept. Okay, so now we can just list, we're done. We can list our x-intercepts. So the first one is going to be 2.2207 plus, every forward movement of a period. So n pi. So that's the period of a function here, not necessarily the period of this function here. Oh no, it is the period of this function here, my bad. And then we're going to look at the second one, so 0.3973 plus n pi, and those are our x-intercepts. So this one was a little bit longer and a little bit nastier, but just go ahead and use your decimals. If you don't feel comfortable finding these positive intercept values, just make sure your work is there and I can see your negative theta values. That's fine. But if you can go ahead and grab those positive values, that is more technically correct. So hopefully this helps with our x-intercepts, and let me know if you have any more questions. I do just want to add a little clarifying note. So just keep in mind, always find your period first, and then kind of make use of that, because that's what's going to determine kind of how far the jump is to our next intercept. So just keep your eye on that. It won't always be n pi. It's going to depend on what your period is.